So welcome back, Abafundi, and we are very close to finishing off our financial maths module and study thereof. So let's just look at an example of calculating a kind of a last lesser payment. So Robbie borrows 50,000 Rand. He repays it with monthly payments of 1,000 Rand starting 1 month from the date of the loan. That's completely normal. There we've got the interest. The interest is 12% per annum compounded monthly. So in fact, the monthly interest rate is 1%, 0.01. How many payments must he make, and what is the value of his last lesser payment? If you haven't tried this question yourself yet, pause the video and let it try it before letting it run again. Okay. Okay, so the first and most important thing is that we're going to be using our present value formula for a loan. Okay, and he borrows 50,000 Rand. So there it is, 50,000. He repays it with monthly payments. X is 1,000. And the question is, how many of these payments must he make? We don't know what N is. Right. What we do know, remember I is 0.01. What we do know is that N is in the variable, the variable N is in the exponent. So we are ultimately going to use logs. But let's see what we need to do first. First thing we're going to do is we're going to divide both sides by 1,000. So 50,000 divided by 1,000, that's very easy. That's just 50. Over here we've got 1 minus 1,01 to the minus N over 0.01. So now what we're going to do is we're going to multiply both sides by 0.01. When we multiply 50 by 0.01, we get a half. No, we don't. Yes, we do. We get 1% of 50, which is a half. And that equals 1 minus 1.01 to the minus n. What we're going to do now is we're going to add that to both sides. So we're going to get 1.01 to the minus n. We're adding that to both sides, 1.01 to the minus n. And at the same time, and I hope you're okay with this, we're going to subtract a half from both sides. So we end up with 1.01 to the minus n equals a half. Okay, that we can calculate on our calculator, realizing that we're going to use logs. Negative n will be the log of base 1.01 of a half. Okay, let's see what that comes to. Log base 1.01 of 0.5, and we get negative 69.7. All right, so n is 69.7. So what that means is that he's going to make 69 full payments of 1,000 Rand, and then one last lesser payment. Okay, so one way of working this out is to work out what is the outstanding balance after 69 payments, and then add 1 month's worth of interest. Okay, so that's easily worked out. Remember, the way we work out the outstanding balance after 69 payments is we're going to work out the value of the loan with interest of 69 months. And then we're going to subtract the value of the payments that have been made, which is a future value annuity. So that's going to be 1.01 to the 69 minus 1 over 0.01. Okay, so we can work all of that out quite easily. Okay, so 50,000 times 1.01 to the power of 69 minus 1,000 open brackets, fraction button, 1.01 to the power of 69 minus 1 over 0.01. And we work out, okay, what we didn't put in is our, I don't think we put in our 1,000 properly. This is 1.0. We left something out here, a very important thing. Okay, we get 655 and 28 cents. But that's the balance after the 69th payment has been made. then the bank will add 1 more month's worth of interest. So our last payment, we need to add 1% to this. So the last payment is going to be 655 and 28 times by 1,01. We're just going to grow it by 1%. Okay, so let's do that. So we're going to go times 1,01. And we get 661 and 83 cents. Okay, we'll check this out just now, but let's do it the other method first. All right, remember that the amount that we can borrow of 50,000, that must equal the present value of all the payments. Okay, and the present value of the 1,000 Rand payments is easily worked out. That's just 1,001 minus 1,01 to the negative 69 payments over 0,01. And then the last payment, and over here I said let the last payment be X. X is not a great variable to use because we've already used X as that's our normal monthly payment. So I'm actually going to change that to Y. Now the last payment in today's terms is actually going to be 1,01 to the negative 70. Okay, and now that's the equation that we're trying to solve here. Right, we're trying to solve for Y. Okay, so what we're going to do, we're going to work out what this stuff is equal to. All right. In fact, we can do it. We can do the whole thing. We can go 50,000 minus. Sorry. 50,000 minus 1,000. 1 minus 1,01 to the minus 69 over 0,01. That will equal Y times by 1,01 to the minus 70. Right. Now, if we multiply both sides by 1,01 to the positive 70, that will disappear on the right-hand side and we'll just be left with Y. So what we're going to actually take is we're going to go 1,01 to the 70, and we're going to multiply that by all of this other stuff. 50,000 minus 1,000, 1 minus 0, 1 comma, let's tidy that up slightly, sorry. 1 minus 1,01 to the minus 69 over 0,01. And that's what Y will equal. Okay, let's bring a calculator up and check that out. Remember, let's see if we get the same answer. Here's holding thumbs. Okay, so 1,01 to the power of 70, and then open brackets, 50,000 minus 1,000, bracket, fraction button, 1 minus 1,01 to 0,1 to the negative 69. And then on the bottom we've got 0,01, and I think we need to close brackets twice. Okay, and that was not even close. So let's just have a look. Maybe just trying to see if I've done anything silly here. No, it actually all looks pretty good. So we've made a silly error somewhere. Okay, notice I've got to the power 69. It's meant to be the power minus 69. That is going to make a world of difference. And lo and behold, I get 661,83. Exactly what we got last time. Okay, and just to close this off, we're going to model this for you on a spreadsheet, just to remind you how loans work. Okay, so we've got the row numbers over here, and what we're going to do is we're going to calculate the balance after each payment. So in other words, the balance after the very first payment is going to be our 50,000 Rand times by 1,01. What that does is that grows it by 1%. That'll be 50,500. We can see there it is. Okay, Just going to make this whole column show as rands. It's a little bit easier to work with. But what happens after that, after the month's worth of interest has been added, is that Robbie makes the payment. So he subtracts 1,000. So that's what he now owes. Now what we're going to do is we're going to press equals, and we're going to take that amount times by 1,01, and then we're going to subtract a payment. Okay, we didn't subtract quite enough. We subtracted 100. We need to subtract 1,000. And now we can just copy this down. So his balance after his third payment is that, fourth payment, after 14 payments, that's what he owes. We can just keep on dragging it down. After 68 payments, he owes that. After 69 payments, he owes 655 and 28. And I just want to go back to here. And that 655 and 28 is the number that we got here with the second method. Right. And then what happens is one more month's worth of interest gets added. Okay, so if we go back to the spreadsheet quickly, we'll see if we now take that number and add 1% to it. In other words, multiplied by 1,01. All right, then we get 66183. And 66183 is the amount of that last smaller payment. Okay, all right, we hope that's helpful. Now, we've got some more practice here, okay, for you to try. And we're going to ask you to pause the video and have a go, and then let it play again. Right, so Mr. Ngwenya borrows 100,000 Rand to buy a car. He repays it over 48 months with interest of that, starting 4 months from the date of the loan. Now that is not normal. Okay, that is what we call like a deferred annuity. It's a bit of a delay before we start paying. Remember what happens with our present value formula. We are wanting the amount that is owing 1 month before the payment is made, the first payment is made. So in other words, there. Okay, right. So we want to know what is the debt 1 month before the first payment is made. So what we're going to first have to do is take the debt of 100,000 Rand, and then we're going to put on 3 months worth of interest. And now the reason it's 3 months worth of interest, right, is because we want to get to a point where we are 1 month before the first payment gets made. So now we've got our 100,000 Rand, 1 plus 0,1 over 12 to the 3. And that comes to, let's just have a quick look. That comes to 100,000 Rand times 1 plus fraction 0,1 over 12 to the power of 3. Okay, not 3 to the power of 3. Okay, it comes to 102,520 and 89 cents. 102,520 and 89 cents. That's how much he owes 1 month before he makes his first payment. Okay, and that is the debt at this point, and that's where we want to be. 102,520 and 89. Okay. Now, what we want to now do is work out our monthly repayment. And this is very straightforward because this is just now a straightforward loan using our present value formula. So this amount of 102,520,89 must equal the present value of a whole lot of payments of X, 48 payments of X, 1 minus 1 plus the interest rate to the minus 48 over the interest rate. Okay, and we'll get our final answer there. Okay, let's see what's going to happen. So the stuff inside the bracket just comes to, remember our answer here is still there. So what we're going to do is we take that answer, we're going to divide by all this other stuff. So it's actually going to be divided by 1 minus 1 plus 0,1 fraction button over 12 to the power of negative 48. And on the bottom here, fraction button 0.1 over 12. Okay, and we get 2,600 rand and 19 cents. So 2,600 rand. What he needs to pay monthly. The question now is, how much interest does he pay? Well, that's really easy to work out, because the amount of money he's paid is 48 lots of 2,600 rand. And let's see what that comes to. All right, that comes to, so I'm just going to take this amount and times by 48. And we get 124,809 and 34. 124,809 and 34. Now that's how much he ends up repaying altogether. But he borrowed 100,000 rand. So the rest of that money is in interest. So in other words, we're going to now subtract 100,000 rand from this result. And so we actually get the amount of interest that he paid is 24,809 rand and 34 cents. Okay. All right. Then another one. Again, if you haven't tried it yet, pause the video and try it. So Mrs. Nele borrows 100,000 rand from her father to go on an overseas holiday, and she repays that much. If interest is that, how many payments must she make? Okay, so 100,000 rand is going to equal, the payment we know is 900, and the present value formula is 1 minus 1 plus the interest rate, so 1 plus 0.06 over 12 to the minus, now she's going to pay for, we don't know how many payments she's going to make, all right? That's what we've got to work out, okay? And then on the bottom here, we're going to have 0.06 over 12. So we're trying to solve this. So we're going to take our 100,000 and divide by 900. That's the first thing we're going to do. 100,000 over 900. That's going to equal 1 minus 1 plus 0.06 over 12 to the minus n times by 0.06 over 12. We're trying to solve this, okay? Ultimately, we're going to use logs, but first, let's multiply both sides by 0.06 over 12. My 100,000, if I divide by 100, just becomes 10,000. No, it doesn't. It becomes 1,000, sorry. All right, if I take 2 zeros off there and 2 zeros off there. So I've just divided both of those by 100, the top and the bottom, times, just to save some ink, times 0.06 over 12. And that equals 1 minus 1 plus 0.06 over 12 to the minus n. All right, now what we're going to do is we're going to add this to both sides. So we're going to get 1 plus 0.06 over 12 to the minus n. And we're going to subtract the stuff that was on the left-hand side from both sides. So this is going to be 1 minus 1,000 over 9 times 0.06 over 12. Okay, and so the last thing we're going to do is put it into log form. So negative n is going to equal log base 1 plus 0.06 over 12 of all of this stuff, 1 minus 1,000 over 9 times 0.06 over 12. Okay, let's see what that comes to. So it's going to be log base 1 plus fraction button 0.06 over 12, and here we've got 1 minus fraction button 1,000 over 9 and times fraction button 0.06 over 12. Okay, and we get negative 162.6. Okay, so n is 162.6. Okay, so what will happen is she will make 162 full payments, and now let's work out the value of that last lesser payment. Okay, and we could use either method. Let's use the second method. Okay, so what we're going to do is we're going to work out the balance, the outstanding balance after 162 payments. So that's after her last full payment. And that's just going to be the value of the loan at that point minus the value of the payments that she's made, future value of the payments that she's made. So that's going to be 1 plus 0.06 over 12 to the 162 minus 1 over 0.06 over 12. Okay, so let's work out what that comes to. So that's going to be 100,000 times 1 plus fraction button 0.06 over 12 to the power of 162 minus 900 open brackets fraction button open brackets 1 plus 0.06 over 12 to the power 162 minus 1 over fraction button 0.06 over 12 close brackets. Okay, and we get 529 and 95 cents. £529.95. Now remember, what we've got to do for that, to get the last payment, is we must add 1 month's worth of interest. So the last payment will equal 5299.95 times 1 plus a 12th of 6%. Okay, so let's just quickly do that. So we're going to go that times by brackets 1 plus fraction button 0.06 over 12, and we get 532 and 60 cents. So the last payment only needs to be 532 Rand and 60 cents. Okay, right, now we've got one more topic to do, and we're going to do that next time, so we'll look forward to seeing you then. Have a great day, everyone. Goodbye.